I will talk about introduction of Sawit Kinabalu Sdn Berhad. This company is investment arm of Sabah state government in the oil palm industry, which is operate as a palm oil producer and a property developer based in Sabah. And it also provides services in planting, processing, procurement and trading oil palm product. And Sawit Kinabalu Group also own and operate 8 palm oil mill across the Sabah, total milling capacity of 435 MT per hour of FFB, and it also can process over 2.5 million tons of FFB. Next, the figure shown about the conservation area by Sawit Kinabalu Sdn Berhad, and I will talk about the palm oil mill operated by Sawit Kinabalu. The first one in KK, which is Lumadon Mill and Langkol Mill, and the second one in Tawau, which is Kundak Mill, and the third one is in Lahad Datu, which is Sabrang Mill, Sandau Mill, Sungai Tenagang Mill, Sungai Sapi Mill, and Sungai Kawang Mill.
So now let's learn on Sawit Kinabalu journey. Sawit Kinabalu Berhad started on 26 November of 1996 when SLDB and BSSB signed a cooperation agreement marked the birth of Sawit Kinabalu. And then in November 1996 until September 2002, a management agreement is established between BSSB and SLDB to manage the operation and investment assets of the residual SLDB. However, this agreement only lasts until 30 September of 2002. After the expiration of the management agreement, Sawit Kinabalu Berhad and SLDB became two separate entities. And then, in 4 September 2007, Sawit Kinabalu Berhad finally changed its name to Sawit Kinabalu Sdn Berhad. So now let me explain to you a brief background on Lumadon Palm Oil Mill. It began its construction in 1998 and fully operated in 2000. Its mill capacity is 45 metric ton per hour and extendable to 90 metric ton per hour. It's processed around 18,000 metric ton per month of FFB or 216,000 per year of FFB. Lumadon Palm Oil usually produce crude palm oil, palm kernel, fresh fruit branch, empty fruit branch, fiber shell, decanter cake, boiler ash, and effluent. For its supplier and customer, Lumadon Palm Oil supplier is from estate, which is contribute around 30%, and private growers contribute around 70%. For the private growners who contribute 70% of the suppliers, 93 of them is registered, while 59 of them is an active suppliers. As for the customers, Lumadon Palm Oil Mill usually get their customers from IOI Corporation, Sandakan Edible Oil and Kunak Refinery, and also local scale. So now, where is Lumadon Palm Oil Mill? It is located in KM16 Bofat Spitang Highway. This mill has land area around 19 hectares with manpower around 108 workers. Mr. Hafiz Hosdi is the current appointed manager for this mill since February 2001. As for the power generator, Lumadon Palm Oil Mill use 3 types of power sources. The first one is steam turbine. The byproducts such as fiber from the milling process will be burned in a boiler to generate steam that going to produce electricity. Steam turbine is the main power sources for this mill, and the second one is biogas methane. The organic material will be treated in anaerobic pond to produce biogas, and the last one is diesel generator. Diesel generator is a power backup for this mill because it is expensive.
There's 2 types of palm oil in Lumadon Mill. The first one is CPO, which is crude palm oil. It is extracted from the mesocrab of the fruit, and the second one is palm kernel oil, which is PKO. This is extracted from the kernel or seed of the palm fruit. Next one, I will talk about fresh fruit bunches FFB in Lumadon Hill. The first one is loose fruit, which is individual detached fruit processed together with FFB. And the second one is empty bunches, which is stripped of all fruit, removed and used as a biomass. The third one is under-rib bunches, which is less mature, and it also have lower oil content than the rib bunches. And the next one is unribbed bunches, which is not fully mature, have less oil, and it processes separately. And the fifth one is rib bunches, which is the ideal palm oil and optimal ribness and oil content. It is also the majority processes. The sixth one is over-rib bunches. These bunches is being removed for the quality. And the seventh one is Partenicarpic bunches. This bunches is seedless and processes with a normal fruit. So the next one is long stalk. These bunches have longer stalk, which is processes same as regular bunches. And the last one is rotten bunches. This is also been removed for the quality.
Let's walk through the palm oil mill process flow diagram, which outlines the various stages involved in processing fresh fruit bunches (FFB) into crude palm oil (CPO) and palm kernel (PK), as well as managing byproducts and waste. The process begins with the fruit cage, where fresh fruit bunches (FBB) are transported. This system ensures that the FFB are moved efficiently to the next stage. Next, the FFB into the sterilizer. Here, high pressure steam is used to sterilize the fruit bunches. This crucial step halts enzyme activity that could otherwise lead to the formation of free fatty acid (FFA), which degrade oil quality. After sterilizations, the fruit bunches move to the stripper. These machines strip the fruit from the bunches, separating the fruitlets from the empty bunch stalks. The stripped fruitlets are then mashed into the digester. This mechanical action breaks down the fruitlets, preparing them for oil extractions. The mashed fruitlets are fed into the screw press, where crude palm oil (CPO) is extracted from the fruit mash. The press separates the oil from the solid components. The mixture from the screw press passes through the fiber cyclone, which separates the fiber from the oil and nuts mixture. The fiber is typically used as fuel in the boiler. The next stage is the nut and fiber separator. The machine separates the nuts from the remaining fiber, ensuring that only the nuts proceeds to the next stage. In the clay bed separator, the nuts and any remaining fiber are further separated based on their density. The lighter fibers float while the denser nuts sink, making separation easier. The separated nuts then enter the nutcracker, which cracks the nuts to release the palm kernel inside. The cracked mixture passes through the shell cyclone, which separates the lighter shells from the heavier kernel. The palm kernels are then dried in the kernel dryer to reduce their moisture content, making them suitable for storage and further processing. The dried kernel are stored in the palm kernel storage facility, ready for further processing or sale. The shell, which are a byproduct of the cracking process, are often used as boiler fuel to generate steam for the mill operations. Clarification process for CPO. The crude palm oil extracted from the screw press first passes through a vibrating screen, which removes coarse solids from the oil. The oil then undergoes clarification, where it settles in tanks to allow solids to separate from the liquid oil. Purification further cleans the oil, removing any remaining solids and water. A centrifuge is used to further separate any residual solids and water from the oil, ensuring it is as pure as possible. The final step in the oil purification process is the vacuum dryer, which removes any remaining moisture from the oil. The purified cured palm oil is then stored in the crude palm oil storage tanks, ready for shipments or further refining. Byproducts and waste management. Empty fruit bunches left after stripping are used as biomass fuel or mulch, contributing to sustainable practices. Decanter cake, a byproduct of oil extraction, is often used as animal feed or fertilizer. Palm oil mill effluents, liquid waste is treated in effluent ponds to minimize environmental impact. A biogas plant converts organic waste from the mill into biogas, providing a renewable energy sources for the mill's operations. Finally, the biomass boiler uses biomass like fiber and shells to generate steam and electricity, supporting the mill's energy needs. First, let's discuss the weight bridge. How is the right amount of raw material ensured? The weight bridge is a critical component in the palm oil milling process. It determines the net weight of incoming fresh fruit bunches and outgoing products like crude palm oil and palm kernel. In this facility, there are two weight bridges, each with a capacity to handle up to 50 and 60 metric tons respectively. This weight bridge uses precise digital weight indicators to track the raw materials, disposals, and final products accurately. This step is essential for inventory management and financial accuracy, ensuring that the right amount of material is recorded and processed. Moving on to the FFB grading platform. Why is grading FFB important? This platform serves as a temporary staging area where the quality of the fruit bunches is meticulously assessed. With a capacity of 360 metric tons, it allows for the visual inspection and grading of FFB based on ripeness, presence of contaminants, and overall quality. Tools like grading knife and visual inspection aids are used to ensure only the best quality fruit bunches move forward. This grading process directly impacts the oil yield and quality, as higher quality FFB results in better oil production. Next, we have the loading ramp. How are large volumes of FFB managed efficiently? The loading ramps, each with a capacity of 360 metric tons, temporarily store FFB before they are loaded into cages. This stage is crucial for managing the flow of FFB into the processing line. Conveyors and hydraulic lift are used to streamline the movement of FFB, preventing bottlenecks and ensuring a steady flow. This organized handling is essential for maintaining process efficiency and reducing delays, allowing for continuous operation of the mills. Let's look at the marshalling yard. What keeps the process running smoothly? The marshalling yard is the central staging area where FFB are organized before being fed into a sterilizer. Efficient use of forklift and storage bins helps manage the continuous flow of FFB, ensuring there is no downtime in operations. This area is critical for maintaining a seamless transitions between receiving the raw materials and moving them into the processing stages, thus ensuring the entire operations run smoothly. Now, onto the sterilizer stations. How are FFB prepared for oil extractions? At these stations, fruit bunches are cooked and softened using high pressure steam. This process is vital for stopping enzyme activity that leads to free fatty acids formations, which can degrade oil quality. There are three horizontal sterilizers here, each with a capacity of 45 metric tons. The sterilization process not only halts enzyme activity but also softens the FFP, making them easier to process in subsequent stages. This step is crucial for maintaining oil quality and enhancing extraction efficiency. Next, let's talk about the tipper. How are sterilized FFB handled efficiently? The tipper plays a key role in moving sterilized FFB onto the threshing stations. Advanced hydraulic systems are used to handle the heavy bunches efficiently, reducing manual labor and speeding up the process. This smooth transition is critical for maintaining a continuous feed into the threshing stations, ensuring that the sterilized FFB are processed without delay. Finally, we came to the threshing stations. What happened to the fruit bunches next? In these stations, fruitlets are separated from the bunch stalks through a process of rotations and lifting inside the threshing drum. This mechanical actions ensures that the maximum amount of fruits is separated for oil extractions. While the empty bunches are discarded, efficient threshing minimizes waste and maximizes oil yield, making this a pivotal step in the palm oil milling process.
Fresh palm fruit transported to cooking pot. There, it will be reheated with direct or indirect steam. A central shaft with stirring fins is installed in the cooking pot. The palm fruit is stirred and the pulp is fluffy and peeled from the core at high temperature. The mixture is then fed into the pressing equipment. The purpose of digesting in the palm oil mill process is to separate the pulp and nut and crush the palm pulp. Then, it is sent to continuous screw press. After pressing of palm oil mist process, oil palm fruit is divided into two parts, which is mixture of oil, water and solid impurities, and the pressed cake, fiber and nut. The pressing process required to extract the palm oil from the pulp to the maximum extent without breaking the kernels, because the palm kernel oil after the broken kernel will contaminate the crude palm oil and affect the quality. The use of secondary and multiple pressing process can effectively reduce the breakage rate of nut. The mixture in the clarification tank is crude palm oil, water and a small amount of solid particles. The traditional method of clarification is to use the gravity separation. The mixture will be heated to 85 until 90 degrees Celsius and then allowed to settle for 1 until 3 hours. The oil on the surface will be sent to a centrifuge to further remove impurity in the oil, and then sent to vacuum. The slag at the bottom of the clarification tank will also enter the centrifuge to recover the crude palm oil inside. And finally, it will be vacuum dried and cooled to about 45 degrees Celsius for storage. Crude palm oil into edible oil require refining process by removing gum, sulfide, color and odor from crude oil. The refining process includes degumming, deacidification, decolorization and deodorization, obtaining high-quality refined palm oil. The pressed palm fiber cake gets into the cake breaker and then get into the winnowing system to separate the fiber and nut. First, the wet fiber and wet nut into the cake breaker conveyor to be cracked, and most of the fiber should be separated by pneumatic fiber depericarpal system. The nut, little fiber and big impurity will be further separated by polishing drum. The separated nut should be sent to a nut hopper through the pneumatic nut transport system and then adopt the ripple mill to track the nut. After cracking, most of the shell and kernel will be separated by crack mixture separating system, and the rest of the mixture of kernel and shell enter to special clay bath separating system to separate them. After this process, we could get poor kernel, which should be conveyed to the kernel to seal to dry. After dried moisture as 7%, the kernel will be conveyed to kernel storage bin for storage. Usually, the dry kernel capacity ratio is 4%, so it should be collected until enough quantity and then be sent to the palm kernel oil mill. For separated shell, it should be conveyed to shell temporary bin as the spare boiler fuel. Palm oil refinery is an essential process for a complete palm oil mill plant because there are still some impurities such as phospholipid, FFA, pigment, odor and others in the crude palm oil. First is degumming. In this step, gums in crude oil are removed by hydration with the help of phosphoric acid. Degumming is the first step for the whole palm oil refinery process. Then neutralization. In this step, free fatty acids are neutralized by using sodium hydroxide and convert them into soap. Additional impurities are also removed by absorption on soap. Palm oil refinery is an essential process for a complete palm oil mill plant because there are still some impurities such as phospholipid, FFA, pigment, odor and others in the crude palm oil. Next is bleaching. During bleaching, unwanted pigment are absorbed physically and oil will become more clearer. Bleaching is also called decolorization. And then deodorization. Deodorization is used to remove unaccepted odor by steam distillation. The odoriferous compound are stripped off with the help of live injected steam into heated oil under high vacuum pressure. Deodorization is mainly for making oil color lighter during palm oil refinery process, which can make oil looks good. The fuel of the boiler is fiber, part of the steam out of the furnace supplied to the turbine generator, the rest of the steam for equipment running supply. Heating system ensure the good flow during the production. All the tank and main machine need the heating by the steam, so the steam boiler will supply the steam for them, including crude palm oil storage tank. Palm oil mill effluent is a wastewater resulting from processing fresh fruit bunches to crude palm oil at the mills left untreated in the open. Palm oil mill effluent decompose organically and these release greenhouse gases like methane and carbon dioxide. Biogas is a renewable energy that is produced from the breakdown of organic waste and is a great way to ensure zero waste in palm oil production. Biogas plants utilize the waste from mills producing energy, which in turn power the mill. Palm oil factory commonly be set in the palm orchard far away from the city. Power supply capacity is low, so power supply should be considered independently. Build a capacity power plant to meet electricity needs of the palm oil factory, which is mainly determined by the electricity consumption of equipment and auxiliary equipment. Generator plant convert mechanical energy into electrical energy. Generator in palm oil mill are often driven by steam turbine or biogas engine. Some palm oil mill have boiler that produce steam, which is then used to drive steam turbine connected to generator. The steam turbine convert the thermal energy of steam into mechanical energy, which is then converted into electrical energy by the generator. Next, biogas engine to generate electricity and drive generator. Diesel generators are used as a backup power source to ensure continuous electricity supply during maintenance or when main generating plant is offline. The raw effluent is a thick brownish color in the viscous and colloidal suspension, which contains high water content, suspended solid, and oils. Effluent exists as an acidic substance with unpleasant odor, high value of COD and BOD, which is contaminantly sensitive to environmental issue. The direct discharge of effluent in the environment is a matter of concern for both toxicology and aesthetical reasons. The majority of palm oil mill use addition of water during the extraction process of crude palm oil from the fresh fruit bunch. As a result, a considerable amount of wastewater was generated and stored in pond. Ponding system or land application is the most widely used at the majority of palm oil mill effluent treatment because of their cost effectiveness, low maintenance cost, energy efficiency, system reliability, and simple design. Numerous physiochemical treatment methods of biological process, bioabsorbent, membrane, and coagulation were employed for treating the effluent. The dried palm kernel can be processed further via palm kernel oil expeller or directly sold to the others. Dry palm kernel final storage warehouse is used for storage of dried palm kernel.
So let's proceed to the advantages of the palm oil mill industry. The palm oil mill industry offers significant economic benefits, particularly in rural areas in providing employment opportunities to sustain and support local economies. The industry is a crucial contributor to the GDP of palm oil producing countries, generating substantial revenue through both domestic sales and exports. In fact, Malaysia is the second leading producer of palm oil worldwide. Based on the statistic, Malaysia price of crude palm oil have reached 4,257 per ton in April 2024. Next is high efficiency. In producing high yield or per hectare compared to other oil crops. It also able to operate continuously throughout the year, ensuring a steady and reliable supply of palm oil. Other major advantage of palm oil industry is in producing wide range of products from food items, cosmetic, cleaning product, and biofuels. This drive to strong market demand relate to its economic benefits. Every part of the fruit able to utilize as products such as palm kernel cake, which is used as animal feed, and empty fruit bunches, which can be converted into biomass for energy production. In the development of palm oil industry, the technology started to improve in processing efficiency and waste reduction. To ensure long-term sustainability and environmental issues, new technologies such as advanced treatment system and methods for reducing greenhouse gas emissions are developed. However, this industry also has its disadvantages. The major cons are environmental impacts due to the deforestation to expand the palm oil plantation. This gives biggest impact to animals, habitat loss, reduction in biodiversity, and exacerbates climate change. Greenhouse gas emission, particularly methane release from palm oil mill effluent, POME, and water pollution also contributes to global warming and risks in human health and aquatic ecosystem. During expansion of palm oil plantation and mills lead to land conflicts with local communities and indigenous peoples. Some labor also reported poor working conditions, including low wage, long hours, and inadequate safety measures in some regions. Next is economic and market challenges. Palm oil prices are prone to fluctuation due to global market conditions, affecting the stability and profitability of mills. These price changes can impact the livelihoods of farmers and the financial health of milling operation. Moreover, setting up and maintaining a palm oil mill involves substantial capital investment and ongoing operational costs, which can be a significant barrier, especially for smaller producers. Lastly, in waste management challenge, palm oil mills generate considerable amounts of solid waste such as empty fruit bunches and kernel shells as well as POMA, which cause serious water pollution. All these waste need to manage to prevent environmental contamination. To conclude, the Lumadon palm oil mill in Beaufort operates efficiently to convert fresh fruit branches into crude palm oil and palm kernel oil through a series of well-coordinated processes. Starting with the reception of fresh fruit branches, the mill undergoes sterilization to halt enzyme activity and loosen the fruits. The fruits are then stripped from the bunches and pressed to extract the oil. This crude oil is purified to remove impurities, while the kernels are processed separately to produce palm kernel oil. Throughout these stages, the mill leverages advanced technologies to maximize oil yield and reduce waste. However, managing the environmental impact of palm oil mill effluent and solid waste such as empty fruit branches remains a challenge requiring effective waste treatment and sustainable practices. By continually improving its processes and focusing on the sustainability, the Lumadon palm oil mill aims to balance operational efficiency with environmental and social responsibility.
Ada banyak ni. Serat-serat. Ayo boleh dimakan dah.